they think. Now, I've got some questions that I dreamed up when I was on the airplane, and some of them, some ideas that I have that I'd like to ask them, but I also encourage any of you that have any questions as you pop up. We've got a moderator that'll run. She's got the microphone, so if you got a question you'd like to ask, you're welcome to ask any individual or ask the whole panel. I think most of the folks up here are pretty bold. I don't think you're going to find any shy people. They'll be glad to give you their thoughts. And I encourage you to give them the hard questions, because one of my mottos is if everybody's thinking alike, ain't nobody thinking. So we'd like to hear everybody's thoughts. This is to be a cooperative engagement. The first one of the panelists that came and tracked me down since I got here was Steve Williams. So Steve, you get the first question. Fair enough? While this might not seem like it touches the warfighter, it gets after the speed of equipment to the soldier. Normal acquisitions can last more than 2 years after there's a legitimate need in the field. Why should the U.S. government move more towards FAR 12 commerciality versus the traditional FAR 15 in this type of environment?
Well, first of all, thank you again for inviting me. I think this is a subject we live every day in Honeywell, because we're really a commercial aerospace company that does roughly about a third of our business in defense. What we see right now in our commercial sectors, especially avionics, navigation systems, the evolution of technology is extremely rapid. And of course, the challenge with the DoD and the current acquisition system, especially with FAR 15, the time cycle of 2 years, sometimes more, especially when we're building up these TINA compliant proposals, really stretches out the lead time to get something done and get it to the warfighter in a time frame that's relevant, so we can take advantage of that technology while it's still an advantage. The current system, in a lot of cases, it's not done. I'm not saying that commercial technology is for everything, but there's certainly a place where it can fit and dramatically decrease that acquisition cycle. Even, I don't know if some of the other panelists see the problem, but we even see with the current capacity constraints in industry, our supply chain's not able to give us a FAR 15 TINA compliant proposal in a reasonable amount of time. So for us to get it from our supply chain and then get it vetted and get it into the government customer and get that vetted and negotiated, we end up with these 1,000, 2,000 page proposals. It's just a very inefficient system. We'll be able to adapt to a commercial proposal, frequently be done in half the time. So, I think it's something that needs to be considered often. The challenge to the acquisition staff is just understanding how to do that, because I know there's a fair and reasonable price. The regulations lay out how to do that, but it's still not well understood. That's an area we all have to work together and make that process smoother. But I think there is a path to get things done half the time and get it to the warfighter while it's still technologically relevant.
Good. And that very, very tactful and nice answer to say that the DoD acquisition process moves at glacial speed. So, but I agree, Steve. That's anything we can do. I mean, the government's looking to do, using OTAs, other avenues in order, because as you say, technology is turning over so fast. We're always behind if we wait for that normal process. So good, thank you. Okay, next up, Dave, you're on. How do you intend to ensure that the future vertical lift investments have applicability to the current fleets?
Well, basically what we're doing is we're taking a lot of our investment and focusing it in the area of open systems. Open systems is really one of the secrets that unlock the keys to the kingdom in terms of going forward and being able to provide enhanced capabilities for the future fleet. But then what we're doing is we're doing it in a smart way so that we're updating the current hardware and software sets so that we can have almost a form-fit function replacement into the existing platforms. Because it's been made very clear to us, future vertical lift is definitely the future, but that future is still 10, 15, 20 years away. So what are we doing today to make sure that the current fleet, which is experiencing the same kinds of concerns and the same kinds of threat environment that changes on a daily, weekly, monthly basis, and being able to get to that open system kind of a standard and architecture to where we can pull it in and we can separate air vehicle kinds of things, which are not going to be touched very often, with mission equipment packages that you can touch more frequently. And you're able to roll things out more quickly, even into the current fleet that we have today. Right. So that's one that we're trying, a lot of our investments are not only good for the long term and the future, but also being able to bring those back into the platforms that are operating today.
Good, great. That's so applicable. One of the criticisms in my old life that we got all the time was, why can't you have a common cockpit? Why can't it be common across all platforms? Real easy to do if we all start on the same day. But we've got systems that, I mean, the Chinook, we're still going to call it the 100-year airplane. We keep updating, and as you say, if we don't have that reverse compatibility, then we're going to alienate some forces. So great point. Thank you. Okay, Cheryl, down at the end, you're up. As an industry provider of mission systems on today's aviation platforms, what challenges do you see migrating over systems of today to future platforms?
Well, you did ask us to think about that. So, BAE Systems, primarily in my area, is a mission system provider of aircraft survivability equipment. And when I was thinking through what you asked, I really could identify a number of challenges. The first being, in order for us to take what we have today, make it ready for tomorrow, we really got to understand the mission of tomorrow and what's changing from adversaries we fight today to adversaries we fight tomorrow. So that really needs to be very collaboratively understood with the USG. The next thing I thought about was what we all think about, SWaP-C, so size, weight, power, and cost. There's a tendency to want to drive that down always. And to get there, we do a lot of thinking about, well, how do we integrate things so that there's commonality and only one of them on the platform? And that really brought me to kind of the thing we have to solve as a community is really thinking, if we're going to integrate reduced hardware sets, in some cases, that's how industry makes their money. They're hardware providers. And if in the future, we're going to be app providers, so we're going to put new software on existing hardware systems so that the USG doesn't have to pay large development acquisition costs, we really have to think about changing the model for the industry. Because right now we fill our factories with hardware and we make our business cases on hardware. Right. So really the biggest thing from my perspective in thinking about, if we have a centralized, say, processor on a platform that does flight controls, engine controls, aircraft survivability, and there is one set of hardware, how are we going to keep industry engaged in innovation and continuing to invest and continuing to develop next generation ideas when there's really the traditional way of looking at it has changed?
Right. Great points. Very, very difficult as we look. We're talking about with the U.S. Army's fleet. It's the largest fleet of aircraft in the world. Just at Fort Rucker in the training base, that's the 6th largest fleet in the world sitting in the training base. So when you talk about doing that and trying to field, we're gonna have to deal with multiple configurations because things are changing over so fast. And how do we minimize that impact and the training associated with doing all that? So that's great recognition of where we're going to go in the future. Thank you. Okay, Ike, time for you. It's Ike's turn to get one now. Ike's from Mercury. How does safety critical parentheses DO 178, DO 254, DO 326 requirements offset or affect current Army fleet and future vertical lift? Why do we need such requirements in sensor processing?
Thank you. Is it on?
Is it on?
Is it on? Can you hear me?
There we go. Hey, you're up.
Thank you for that question. I think it's critical to really think about safety in this environment.
Uh-oh. I'm not sure that thing's working. Susan, let's try yours.
Okay. Does this work?
Yeah.
Great.
There you go.
So I think it's really critical to think about safety from both civil aviation as well as military. Mercury modules, all the way up to subsystem that's safety critical, that meets safety criticality of FAA and EASA. And one of the things that we have to really understand is, especially in light of 737 MAX fiasco,
Right.
Safety is critical, especially in military aircraft. They have to fly within the civil airspace as well. They have to share the airspace. So safety is very critical. And a lot of people say, hey, if the safety is so critical, what path do we have to follow? Previously, we actually had a different safety criticality, whether it's Navy, U.S. Marine Corps, Air Force, or Army. Now we're thinking about trying to follow the same process of FAA and EASA, which is the right path. And the thing that we have to really worry about is that all the sensors that's coming out, whether it's radar, EOIR, IRCM, RWR, MWR, all those sensors that we actually attach to our military aircraft also need safety criticality. And a lot of people ask why, and the reason why is that we use those sensors for navigation purposes. Whether it's a visual navigation or DVE kind of landing, you actually need those safety critical capabilities. So I think it's one of those things that is not only necessary, but it's actually absolutely fundamental architecture that we have to start out with when we actually build a next generation architecture.
I think that's so critical. One of the things that, I'm an old acquisition geek, but the thing, we may have been slow in the processes and working through all those things, but the safety of the soldier was always number one. And if we lose that confidence, if the soldier doesn't maintain that confidence that we're giving them, we collectively are giving them systems that are safe and allow them to do those high threat things, we will lose that. So maintaining those standards is critical. That's very good, appreciate it. Okay, Susan, you've been sitting there quiet, it's your turn. How does the Army's focus on future vertical lift impact how Northrop Grumman approaches the Army's modernization challenges? Easy question, right?
So right now, the Army's been very focused on what is the family of systems and the core capabilities that we need to do. And in that, Northrop Grumman is taking a look at how do we explore the overall FAR mission space and take a look at it from mission and technology integration things that we have. First thing to take a look at is the world that we're looking at is in MOSA. So as you're developing the next generation system, sticking with the open system architecture to be able to quickly update systems for plug and play as the threats evolve is key. As we're taking a look at that and how do we integrate the different tactical sensors and capabilities into the overall kill chain. The other thing that we're seeing right now that we've changed how Northrop Grumman is taking a look at it is really where we're looking at more of the hardware-enabled, software-defined type of systems and taking a look at what are the multifunction capabilities that you can put into individual sensors. One of the things that we see as a challenge, though, is what is the buying patterns as you're looking for multifunction systems with the Army. As you take a look at typically the way the funding profiles are individual stovepipes, but as you're coming up with more multifunctionality, single apertures that can do comms, that can do radar, that can do ASE type functions, is how do we do that? But we're trying to take a look at prototyping some of those capabilities to show the trade space and how we can save swap and cost, which is one of the major functions that's going to be limiting systems going there. But in all of that, two other things that really come in there that are underpinning is the cyber resilience. So we're making sure the systems that we're looking for, kind of with the safety perspective, also that they're cyber resilient, that the bad actors that are going to come in and take a look at the systems are unable to go ahead and penetrate the systems that we have. And the last thing that's changed kind of the way that we're thinking is all the rapid prototyping. How do you use vehicles like an 804 vehicle or other types of applications to get the rapid prototyping and get capability out to the warfighter sooner to be upgradable, but not the long acquisitions, as was discussed before, and how do you change that, and how do you do that, and how do we position to get capabilities incrementally updated quicker?
Good. Yeah, the rapid prototyping goes back to what Ike was talking about with standards. You know, you can go fast, you get it fast, but you may not be checking all those blocks. The one point you mentioned that really resonates with me is we got great partners in industry, we got great engineering communities within the government. What we don't have, in my opinion, is the ability for the funding, types of funding to accommodate the kind of innovation that they're talking about. Because you may pay some science and technology dollars to do some rapid prototyping. You may have some procurement dollars to go procure that capability. But then that rapid upgrade and that you have to do, that's a third funding peg called sustainment that resides in another agency. So maintaining and planning for that and being adaptable, that's a challenge of the government to be able to recognize that and allocate that funding accordingly. That's going to be a challenge we got to face. Good, thank you. Juan, you're up, dude. In the past, going with small business has been deemed as risky by a lot of programs because of their small nature. POC is kind of one of those small guys that's innovative. How does POC specifically reduce risk for their customers to convince them to go with the small?
So first off, I'd like to say thank you for having us on the panel, or POC. As a small business, we take this opportunity very seriously in how we present ourselves as a small business and what we offer, our DoD customer. So how we reduce risk, at least in our minds, is making sure that we have all the standardized things or items that the big guys have, like a BAE or a Northrop Grumman. We are AS 9100, 9110. We're also a CMMI level 3 software house. Out of the whole country, there's only 6 companies that actually have that, and we are the only small business in the country that has all 3 of those certifications. So as we look forward, as we, POC, look forward to move forward and do more business with our customer, we want to ensure that we're taking that standardization, that you're not losing any level of quality, any level of standardization, or any level of support that you would normally get from a larger company when you go with a small company. And the reason why is because we're actually kind of hungry as a small company. We want to get that business, we want to maintain that business. So that's part of our whole customer service package. We at POC like to say we don't like to leave our customer with any problems at any time. Whether it's on their fault, whether we didn't train them well enough on how we implemented the system that we gave to them, or whether or not it's our fault that we have some sort of design problem that we need to have fixed. Now granted, we're a small company and we can only do certain things. So capital and funding is very important and we keep that very close. But in whatever the situation is, as an example with the T-45, we have a mission computer called the DDS that flies on the T-45. When they had a fleet-wide problem with the DDS interfacing with the rest of the aircraft, we went down to Kingsville, we went down to Meridian. We actually sat there for 3 weeks with our engineers to figure out what the problem was. And the problem wasn't with our DDS, the actual problem was with the aircraft. Mm-hmm. And we helped them find out and root out that problem. And we did that all at our expense because we feel that our customer is the #1 priority for us as we move forward. And as we said before, and as the rest of the panel said, safety is vital and critical for our warfighter.
Great. Well, I appreciate that. He is the small on the group. Of course, small wants to be like all big guys. So, but it comes with, there's affordability questions. And to me, when I immediately think about it, I look and think about partnering opportunities and how we can, smaller companies, can be a little bit more dynamic and innovative sometimes, and the bigs almost start looking like the government sometime when they get that big and get a little bureaucratic. But that's why I asked a small company to be on there. Just give us their perspective. I suspect some of y'all would discount some of the things he said, and he would probably discount some of the things the big guys say, but just an opportunity. Sean, you've been very patient. You're up. What do you see as the key enablers for industry to evolve the future state of the Combat Aviation Brigade, particularly with the UAS capabilities, so we try and continue to foster demand and unmanned teaming?
Right. So the chief challenge to me of integrating UAS capability into the future force is managing the burden of the complexity. Where the capabilities reside organizationally, how they're fought, where they're fought, are things we're wrestling through on the future side of the capability sets. And it goes beyond the material solution. It's one thing that we found in terms of flying an aircraft, nearly 2 million hours between our platforms, but as Army Aviation in general, there's a lot to be learned. It's one thing to build an aircraft, it's another to employ it effectively and generate that confidence in that solution so that the aviator can still aviate and knows that if something goes wrong, knows how to fix it and be effective and successful in that mission. Key enabler, there are technical aspects to that enabling capability, data links and comms and the physics of interconnecting these different platforms to achieve very large objectives in combined effect. But ultimately, I think it boils down to that partnership word that you mentioned earlier about the speed at which the technology can be fielded, supported, sustained with the parts and the supply chain to support it on the back end to support the mission need, but also make the changes because when we have our fee-for-service business, for instance, we're out there flying missions, various payloads, different mission sets, site to site, flight to flight even. Things can change quickly and it takes speed to get that idea pulled back into the teams that can solve it with the end user's input and drive that capability out into the field with that confidence so that when it gets degraded, denied, or compromised for whatever reason, the system and the mission can still be effectively conducted.
Good, great, thank you. I think about UAS in the future, we tend to, it becomes very easy for us to think about things that we're comfortable with and we do on a day-to-day basis. Many of the things that you and your companies do, you're looking and trying to read the future. I sit there and I think to the future. 10 years from now, my gut tells me we're not going to be training pilots like we train pilots today. I kind of feel like we're going to be training mission managers, and the sensors and the capabilities and the things that y'all are building for these airframes, the airframes are pretty much going to fly themselves. And the pilot or the mission manager or whatever you want to call him or her are the ones that's going to be trying to sense what all of those sensors are telling them and make engagement decisions based on that. So the rapidity of change in this environment of linking all those together is going to be something for an old guy sitting on the porch to watch and be jealous that he's not part of anymore. So great. Do we have any questions so far from the audience? If not, I'll keep going. We got one over here.
Hi, thanks. I guess this is a question for the general panel. I got a lot of experience in the open systems area, and one thing that I've noticed, and I'm hoping we're going to see a change, is that it's possible to conform to an open standard, but still bury either integrator or vendor locks within the solution. So you can check the box in all the open system, yet still have a proprietary middleware or need to use a proprietary tool set to integrate the system. So I guess my question is, and I usually know why they do it, is because it's hard to build the business case, which somebody talked about earlier. So the pressure from the intellectual property people is to put those kinds of proprietary hooks in there, still be able to check the box that you've got an open system, but in the end, you haven't really met the spirited intent of what MOSA talks about with building an open system that doesn't have integrator or vendor lock in it. So I'm wondering if you could comment to whatever analysis work you've all been doing to find out, is there a real business case for you to be truly open according to MOSA, or is it business as usual where you'll just check the box on OSA saying thou shalt be conformant to an open standard? Yes, we are, but we still have vendor lock in there and propose that way.
Okay, who wants to jump on that hand grenade?
I'll go ahead and take a first stab at it. And it hits on a lot of the things that Susan was mentioning before in terms of how industry in partnership with DoD entities, and I think this is not only playing through in the Army, it's playing through in the Air Force and Navy and the Marine Corps also. And it's really a shift in the whole business model, not just the business model that we're trying to, because exactly to your point, if you try to have the acquisition system work the way it does today, and you just throw in that we're going to do open systems, then it breaks down fairly quickly. I think one of the things that early on in the FACE consortium that everyone agreed, this was government and industry alike agreed, was that there had to be a shift in the mindset of the military also. And I think that's part that we've seen a lot of advance in terms of the military and the acquisition authorities looking at it from the perspective of it's not, we have to, industry has to make something for them to be able to want to be there. And that's where the control over the interfaces was really what they were settling on, was the interface needs to be the common standard that we share, that they share, that everyone shares. The challenge is that you have to stay in that house. And oftentimes what people, we start to hear on the periphery is there's a little bit of, we want our cake but eat it too. And it starts to be, well, we not only want the IP for the interface, we want the IP for the magic inside whatever app it is. And I think that's where we have to just continue to remind both sides that there's a partnership here. And really the way that you can engage in that partnership is going to be so much better for everybody, because, think of a world in the future. And we did a demonstration with the Army it was about 4 or 5 months ago that showed, here's a digital backbone. Now we're going to show you on that digital backbone a Collins app running. Now we're going to show you an app that was developed by Army Engineering. And now we're going to show you an app that was built, honestly, by a small company, a third party. We're all building to the same standard. And when you look at the power that brings, because that means everybody across this stage now can plug into the backbone. We all can. Now, I know, at least speaking for Collins, we don't have enough money to invest in everything. But the things that we do invest in, we think we do pretty well, and let's be able to put that out there and populate that. If somebody else does the best contested waveform defense, then let's be able to have a backbone that can actually be leveraged. And I think that's where the win is. There's a business case that industry can live with, but the win from the military perspective and the acquisition authorities is they get a much more capable system that really meets these threats in a much more timely manner.
Anybody else want to comment on that one? Susan? Cheryl, you want to go?
Yeah, great question. I think you nailed it. I agree with the gentleman who just kind of laid out what the challenges we see. I mean, we need a paradigm shift. And if you really look today at the way we do business, the business cases don't close. So in order for us to do things differently, the whole community has to move in parallel. It's not going to happen just if a part of us moves.
I was going to say something. I was going to say something very similar in that from a business case perspective, the business model needs to change a little bit. I think some of the paradigm shifts that we're seeing with other customers in other areas is that some of the IP, as he was saying, could be encapsulated in some of the apps that you bring, but the overall interface and the ease in going in there needs to change. As far as also developing the business case for rapidly changing threats and needing to update quickly, you need to prove yourself. You can't just say it's a vendor lock because of the IP. It has to be the best thing for the mission and the things that are changing. So that's some of the conversations that we're having is how do you stay ahead so that you earn your place on the platform. It's not just because you are there because you have vendor lock, but you've earned your capability. But it has to be a change in the model. And then also what the business makes sense to go ahead and take a look at it. And it is going to be across the industry. It's not going to be just one company or person doing it. It's going to be kind of working together.
So let me just take a stab at this because I think it's really important on the vendor locks. My perspective is that, from as we go forward, it's going to be a lot more software driven. I mean, Susan said about, software defined, and it has to be software defined. In the future, we have to have sensors and hardware a commodity. That's the only way for us to make a IP a asset for a lot of companies that we have. And if you don't have a software as a main driver, then we're not going to have the upgrade capability as we need. Because hardware doesn't get upgraded every 2 to 3 years. Hardware gets upgraded every 10, 20 years. Mm-hmm. But software capability needs to be upgraded very, very fast given the hardware that we have today. So I think we have to really think about the vendor lock from software perspective rather than the hardware perspective.
Mm-hmm. I think that's a great point. Anybody else want to jump on it? As we look to the future, I think I hit right on the word. What the government's trying to do is avoid vendor lock and getting committed and stuck, both hardware and software, to a potential vendor. The government wants to be able to manage it. But the pendulum swings. There's a lot saying we need to own every TDP. Well, everybody sitting up here knows that just because you own a TDP doesn't mean you can build it. Doesn't mean you can manage it. No guarantee. You don't have the secret sauce. So what we're looking for is the government wants to be an informed buyer and doesn't want to be locked. They want to be able to take advantage of all of the expertise of our great industry partners. And we've got to find a way to change, Susan, as you said, change the business model to incentivize our industry partners to be able to be willing to do that. So your point's well taken. We got to get away. I guarantee you, if I had all 7 of these folks up here write what they thought the definition of open system was, we'd probably get 7 different definitions. Get pretty close, probably closer than most of us out there. In my old days, I was known for gross oversimplifications, but I looked at what we're talking about in an open system is kind of like the cigarette lighter in your car. Does anybody smoke anymore? Not many. But everybody knows if you want to operate in that vehicle, you got to be able to plug into that cigarette lighter. You know what the volts are, the amperage, all of those things. So I think what we're trying to do, we're trying to be informed and have the ability and the agility to maintain those sensors and give the soldier the best. But with that, we can't just say we want it. We got to find a way to incentivize you, which means changing that business model. So great question. Another question in the back. Please go ahead, sir.
I heard loud and clear that acquisition system in the U.S. Army is sort of slow, kind of slow. I hope so. I hope I heard it right. See, I am an aerospace engineer for U.S. Army. What I want to know, do you have any business model or a suggestion for a rapid product U.S. Army on current legacy systems for innovative ideas? I have not seen any like that. I've been in 20 years. I have not seen any. Why is that? Why you have to wait for a vertical futurist to come for 10 years from now? Why not do it now? lessons learned is how you do the innovation. Can any of you answer this?
So I'll take a stab at that one first because that's right in my wheelhouse. So as a small business innovation and research, the SBIR program actually allows for exactly what you're talking about. It allows small businesses to compete on topics for innovative ideas that the programs have or that the engineering directorates have. They submit those topics to the small businesses, and the small businesses compete. Once their design is actually at a certain level and has been accepted, they win a contract to mature that further. So that's called a phase one. At the end of a phase one, normally we have a white paper or something like that, something at a TRL about 2. If we get accepted and now we have a proposal for a phase 2, now that goes to the next step. At the end of a phase 2, after some investment by the government, which is not from the program, by the way, this is from the Small Business Authority, then you're going to be up to about a TRL 5 or 6. Now the program can take over. This idea, which actually came about from the directorate or from an engineering directorate or from the program office, has now matured all the way up to a TRL of 6. Now it's up to the program office or whatever community that's actually supporting it to bring that to a TRL of 9 and bring it into production. So small business is doing that every single day. There's 3 phases or 3 times of the year where an SBIR topics are actually laid out. So we have, like for this year, for example, they come out in March, June, and October. So out of those, you probably have across the whole federal agency, which includes the DoD, Department of Homeland Security, Department of Transportation, etc., you probably have about 400 topics coming out every year on that exact thing. So my advice to you would be is to get on that, talk to your SBIR advocate of whatever directorate you're at, and submit your topic, because someone will pick it up and someone will fight for it.
That's a great point, but again, the SBIR is a great capability. OTAs are a great capability to get things started. But for a small business, which you bring that innovation, on the larger businesses, we in the government fail to realize, or I say fail, we quite often forget that these big companies, any of the companies, have to go back to their leadership and encourage them, convince them to invest in these things. And quite often, based on the ever-changing and rapid-changing priorities and the funding streams and those sort of things, they've got to be able to substantiate to their leadership that there's some production arm. There's something that's going to be a return on the investment to their stockholders. So quite often, what I affectionately call the good idea fairy, which is very important, we need people to be coming up with new ideas. There's got to be some foundation and basis, or at least some path ahead to be pursuing something like that for y'all to convince your bosses to go do it. But as you say, we got to push technology. The SBIR is a great opportunity to do that.
And the
They'll get you on too. Give them a minute. They got flip switch. You're good.
Hello? Okay.
Yep.
So the advantage to that actually methodology is not only can the Department of Defense take advantage of that, but also the large companies who also have a small business kind of requirement based on government contracts, they can also take advantage of that innovation as well. They can help support, they can help fund, with internal IRAD funding. So all of this kind of comes full circle. What I've noticed since I've retired from active service and got into industry is that even as a program manager, when I was a program manager at NavAir, I couldn't spell SBIR. I had no idea what it was. Until I actually got approached by a small business and actually went through the whole function, went through the whole process of that. And now I work for a small business, understanding what the constraints are from a small business, funding-wise. These guys have the same constraints, albeit on a larger scale, but they have the same constraints, and even more so. So it's harder for them. But we're here to try to make it easier. When you're talking to industry, don't just talk and think about how a big company can do something for you. You have to think about how a small company can do something for you as well.
Right. But again, good points, but from his perspective, he's also got to think about, he's trying to change something in the fleet. Steve, you have some comment?
Yeah, I just want to add a small comment on that. I was just recently in a roundtable meeting with Dr. Roper in the Air Force. We talked about this subject specifically, and he encouraged us, large prime contractors and subprimes like our company. There is a lot of money out there, $1 billion, $2 billion in small business funding that's available with, frankly, very little restrictions. It doesn't have to go to SBIRs, but partnering with us to help the small businesses get across that chasm. Sometimes there's tremendous opportunity in contracting mechanisms available through OTAs to take advantage of that funding, to take, our companies sometimes have a hard time making that business case to take on that risk. Now, if you bring small business funding, and it helps us get over our own internal business plans to make that happen, gives opportunity to small business to get exposure and also have a strong partner to cross that chasm.
Great point.
There's a tremendous opportunity.
Great point. Sean, you want to jump on that? Or Dave, did you? Go ahead, Sean. Sorry. We'll
Yeah,
get
I think
back to
one
you.
of the things that stands out, the active S&T world, science technology world, the experimentation is how do you get past the valley of death out of that into a fielded solution? And that's a challenge that you talked about leadership from our business side. We want to do this work, how am I going to get it into the program, how am I going to help the fleet? That there is a challenge and an onus on the leading edge development side to bring with it the credibility and the substantiation that can support a program. And probably chief among them is the economics of it. There's probably rooms full of good ideas. There's probably even more rooms of good hardware and technologies that could be applied to the current fleet that just aren't economical for vendor lock situations, perhaps driven by the architecture or the cost of verification. And as we start looking towards autonomous systems, and how you interpret that, but systems that become harder and harder to verify, the cost associated with that becomes increasingly high. And the architecture, open architecture helps facilitate that, but getting to that valley of death from the development side, we've got to put a little more work in justifying it, not only from a business standpoint, but also technically and from an operational PM standpoint to buy into that.
Good, thanks. Dave, did you want to say some more?
Yeah, that's a great question, and that's exactly where in the example I gave before, that's what we see the same thing. When we're making investments, for example, in multi-core processing, that we'll have a civil certified multi-core processor in the next several months. Those are the kinds of things that make a difference in the basis of the question the gentleman asked. How do we actually take that processing capability and apply it to a new environment, to a new set of challenges,
Right.
and come up with something that not only fits future vertical lift, because we've been told, time and time again, the threat isn't 15 years from now. The threat that needs to be met is today. It's tomorrow, it's for the next 10 years that we're going to be dealing with the platforms that are flying today. So we're actively looking at how we can add additional capability, incremental capability enhancements by using the same form factor, the same volume, but adding more processing into it, more apps into it, given that open backbone we talked about before.
Good.
Great
Thanks.
question, though.
Thanks. Yes, ma'am, go ahead.
Good afternoon. Tim.
You don't get to ask any questions, Tom. Go ahead.
Panel, good afternoon. So I'm formerly Boeing, spent nearly 30 years there. I'm currently working with small business in the autonomous systems sector. The SBIR system, as you point out, is actually pretty darn good about expressing what the government is looking for in terms of initiatives. Having said that, if I went to Textron and look at your site, it's going to be difficult, just like it would be with Boeing. It would be really nice if we could get a coordination between the SBIR and the small business work that's being done, not necessarily in terms of specific tasks, but in terms of announcing 3 times a year for initiatives, so that you, as a little supplier, you've got an opportunity to look across the spectrum. So is anybody able to address how the big companies can look at that?
Well, I'll jump on it first. Well, great points. There's organizations within the Army. Lane Merritt is now acting for Bill Lewis, who just retired, and the capabilities they have to take all of these things that the good idea ferries are generating and making sure that they're linked to a warfighting requirement, some gap like what Dave's talking about, to go after and then consolidate, and then that hopefully will help evolve in the requirements, now that they belong to the Futures Command, evolve in the requirements to give a funded and stable requirement to this team to go execute. So that's immediately when I hear what you're saying, that's what immediately jogs in my mind. I invite anybody else to jump on it. Crickets.
I guess, just a couple thoughts. I think exactly to your point. I don't think industry ever gets to a point where we're as formal as what the government has with Commerce Business Daily and all the ways that they can
Please don't
that.
get as formal as the government, okay?
That might be a good, good news, bad news. But I think what we do is we try to get the word out that, these are the kinds of things. So in the demo, again, that I mentioned before, we're actively looking for folks that are investing in areas that we know are important to our customers. Whether it's a rotary wing customer, a fixed wing customer, a UAS customer, we're hearing all these needs, all these challenges they have. Who's out there that has innovative solutions to do it? Whether a big business or a small business, as I said before, we've acknowledged long ago that we can't afford to invest in everything. So where is it we're going to partner? Who are those partners going to be? And once you find an innovative company, you know, and really that's the neat part of this open systems is it really starts to turn loose the power that's in some of the smaller companies that never had an avenue before. But those are the kinds of companies that we're looking at partnering with so that we can provide an all-encompassing solution to a prime or, you know, in the end to the U.S. Army.
Good. Ike, you want to jump?
So I think that's a great question. I think, you know, from Mercury Systems' perspective, we always look at small companies, but not only small companies who are associated with SBIR, but small companies in Silicon Valley as well. It's kind of interesting that we have to leverage all the technologies that's out there. I mean, there are, you know, VCs spending billions and billions of dollars in urban area mobility, you know, autonomous, you know, piloting. All that information, artificial intelligence. If you don't leverage that, you know, SBIR is a small component of how we need to partner to support the warfighter.
Good point. Okay, we up? Anybody? All right, we'll go back to my questions. We'll go in reverse order. Sean, you're up first this time. The future state of the Combat Aviation Brigade will likely include an expanded family of UAS capabilities. What challenges do you see with realizing that objective?
Yeah, I think I touched on a number of those on the first question, but as you start looking at how these systems fit in with combat aviation, beyond what they do today, I mean, you know, the Shadow, for instance, does man-on-man teaming, increasing standoff and reach for our combat aviators. Looking beyond that, coordinating all of those platforms to provide combined effect and having distributed command and control of that effect represents a pretty significant challenge in how you control, command, and provide that confidence to go deploy. So, you know, we found, you know, open systems in terms of easy ways to help or mitigate the challenges of integrating it from a functional standpoint. But the human agent, that operator, aviator, the ground user that is signing up to use these capabilities, how do you train and sustain that? There's a lot to be learned, a common cockpit to the comments earlier, and the automation and autonomy in general, that big word, you know, getting from point A to point B, the aircraft flying itself, that's one component of it. But things like maintenance, how do you automate maintenance so that the check engine light comes on and has corrective action so that the user, whatever echelon they're attached to that's flying this very large and complex machine to do a mission, is able to respond and task that vehicle to go home, return to base, and then once there, how is it serviced so that vehicle can be back in the fight. Putting stuff at arm's length is great to get you out of the way, but it's hard to turn a wrench when it's, you know, 20 clicks away. So that challenge of getting that automation in really comes through that idea of rapid validation in fielded environments. So it's only so much you can really do in a lab or on paper and through analysis. You got to put it in the mud, you got to put it in the dirt, you got to put it in the fight, and learn those lessons very quickly. To that comment earlier about rapid innovation through tests and evaluation. The challenge is how do you do that economically? How do we do it fast enough to support the informing these future requirements? That presents itself in many ways. You start looking at different classes of vehicles being used in vastly different ways than we've used UAS over the past 20 or 30 years. Good,
thank you. Okay, not that we've already hit this one, I'll give you another chance to get on the SBIR train. For one, in general, how does the SBIR process work, and how can the CAB benefit from this process? We've talked a lot about that, but give us a couple of specific examples, I think, where you think we can do that.
Yeah, I think we've already gone over the SBIR process a little bit, but in that, so our company, POC, we can actually help out the CAB by giving them something innovative on a much shorter timeline. So because of the SBIR process and the development that happens at the front, at the front end, you're already looking, when a program is starting to look for some of these requirements that they have, they're going to start at a TRL of 6 for that product and then be able to move that forward. As you get to a phase 3 and a program actually comes to a small business with a contract, it's very flexible, because a phase 3 actually, all you have to do is whatever derives from the SBIR topic that you had. If it derives from completes it, or extends the SBIR topic, then you can actually get into a phase 3. And the positive of that is you could go sole source with a small company. Because you've gone sole source, now you take out the competition or the competitive time frame that you had before where you had the competition. So now you can go direct to a small business, direct to your development effort, and you can skip the year-long process of what you've had in that competition effort. You're already starting out at a TRL of 6, so you're already kind of ahead of the game. So when you're looking at development, you can actually bring that to bear at a much faster rate than what the traditional acquisition process actually gives you. So my specific example is when I was at NavAir, I was the Common Systems IPT for PMA 299 or the H60 program office. At the time, we were looking for an advanced data or a data transfer system that was going to be able to bring moving map to the aircraft. Because as a Navy guy, we didn't have moving map even as far back as 2003. When I got there, one of the problems was that our commodity PMA was going to actually fund that and do that across all the different platforms that NavAir had. The problem was that when I got there in 2011, they said our IOC date for our DTS was going to be in 2020. That was unacceptable to the fleet. So we searched out, looked for a company, found a small company that was going to be able to do this, and we pushed the schedule to the left by 2.5 years. Not only did we push the schedule to the left by 2.5 years, because we were able to really tailor the development to NavAir requirements, we not only got it on the H60, but we got it on the V22. It's going to go on the H1 here pretty soon, and it's flying on the CH-53K. So realistically, that one item is going to be flying on 7 different type model series aircraft, and it saved the government, by the government standards, not small business, but by the government standards, $258 million over the life cycle of that program. That's the type of innovation and product and value that we can bring.
Good example, thank you. Susan, you're next. We got about 8-9 minutes left, so we'll try and go quick with these. What can industry do to help the Army become more lethal and more survivable as our threat environments evolve into a more complex peer and near-peer tactical operations?
Yeah, as we discussed before, the threat is changing at quite a pace that traditional acquisition systems and traditional acquisition timeframes don't really support meeting those needs. So a couple of things that we're looking at from an industry perspective in Northrop Grumman is one, looking at using higher TRL building blocks, leveraging other people's money as well from other services to bring those solutions down to the Army, since traditionally the other services have a lot more fundamental research and development dollars, and how do we bring those higher level TRL building blocks into the solution set? Creating common system architectures also help with perhaps doing cross-functional collaboration, man-on-man teamings, such thing as counter-UAS, and taking a look at that there. Bringing those agility things in there also bring you to systems like we talked about rapid prototyping going forward. The other thing is working very closely with the Army to understand the needs and what the architectures are that they'll be plugging and playing into. So from an open system architecture. And then really the affordability piece is also key to us too. If you have solutions that are not breaking the bank and that can bring that in there and you can share the development across multiple services, across multiple products, you can bring a capability that's better than just doing one person. And then the multifunctionality also is how do you go ahead and share common flexible architectures and flexible systems so that as the threat evolves, it's just really putting in more software to go in there. So it's back to that software-defined, hardware-enabled, and as the threat evolves, it's just kind of an app. It's like an app for your iPhone. You can put a new app in there, and being open architecture allows you to put those apps in without having to change the hardware.
Right, great, thank you, super. Okay, Ike, you're up. This is a deep one, you ready? How does Moore's Law impact avionics architecture? And what do we need to do differently to take advantage of processor speed improvement in light of all the things that Susan was just talking about?
Yeah, that's a great question. I mean, what Dave said about having a multi-core processor that we have today. So Moore's Law basically says the process speed doubles every 18 months, right? So if you look back, go 2004, which is 15 years ago. So we should have doubled 10 times. So 2 to the 10th is 1,000 times. So if you design something in 2004 versus what we design today, we should have 1,000 times more faster processors today.
Right.
So if you look at the duty cycle of most of the processors today versus something that was designed 15 years ago, duty cycle is still 50%. So what does that mean? What that means is that we're not using the processor effectively. Because I know that we don't have 1,000 times more functionality than we had 2004. So basically what we need to do is that we need to really challenge our the evaluation criteria such that you have to have a duty cycle so that if it's 1,000 times more than 2004, then our duty cycle has got to be sub 1%. So we really need to go back to the acquisitions and really, really challenge ourselves to ensure that we use those processors efficiently and effectively.
Right.
Because right now, I believe that we have a lot of spaghetti code and software entropy. And if you go that route, you're not going to get more functionality,
Yeah, good
basically.
point. Good point. Great, thank you. Okay, Cheryl, wake you up from your afternoon nap down there. We've been letting you be so quiet. Okay, it's your turn. When you think about the architecture of mission systems on future platforms, do you see them as, I think this is really an important question, do you see them as federated or integrated?
So, pretty sure any vendor on this panel and any vendor in the audience could take their expertise, parlay that into a differentiating capability for the warfighter in a federated system, right? So as we move forward and we talk about the benefit to the platform, it's got to be integrated. But there's a couple things we talked about today, and the gentleman's just leaving now. Got to wave. Right, we need a paradigm change in order to enable that. But the other thing we have to think about is when you have an integrated system that services many capabilities platform-wide, that system becomes much more interesting to the bad guys from a cyber attack perspective.
Certainly, great
right?
point.
So really architecting for redundancy is key. Architecting for hardness, one attack could take out the entire platform. So it really does need to be thought through. And there's a couple significant challenges we've got to face into there.
Right. That sounds like I went to the old DCMA program management courses years ago, and every question we asked, the answer was always, it depends. And so I think your point is very well taken. Thank you. Okay, Dave, your last question. We're going to push our time. We're going to make it, I think. How can the industry provide capabilities at a more rapid pace to meet the ever-evolving needs of the warfighter? Similar question to what others have, but let's get your perspective.
Yeah, we talked a fair amount before in terms of, it's a huge piece of that's the open system, being able to build that digital backbone, and then being able to separate what goes on the mission bus, if you will, vice the air vehicle bus. And I think that's something that there's a little bit of I'll say almost a debate that was created between, companies like Collins or Northrop or others that are, kind of in competition with prime vendors. And I think the way we tend to look at it is it's not separating the two so that you can totally separate and have a distinct, mission equipment package that's totally separate from the air vehicle. It's how do you have something that complements it? There'll always be an integrator kind of a function, but as we build that digital backbone, how do we do that as a team? The OEMs, the subprimes, the third parties that are all playing in that to be able to come up with a system that meets the rapid fielding requirements that the Army has with this expanding threat that they have. It gets into what was mentioned before in terms of not only the technical pieces and do you have the processing speed, it's have you protected it from a cyber perspective, have you done everything in terms of the architecture that allows us to really accelerate speed to the field, because that's what we're hearing time and again from all our customers.
Great point. The VLC, the consortiums that funded, as you say, I think the key word, easier said than done, is complementary, that we complement each other. So that's a great point. Thank you. Okay, Steve, your last one on the barrel here, and then we'll cut everybody loose. With the lessons learned from the past and FVL coming on like a locomotive, how does the Army balance capability and cost? From propulsion to mission equipment packages, how does the Army get the capability they need to expand the battle space and do it in a cost-effective way? In other words, how do you solve world peace? Come on.
Exactly. There's a lot in that question, sir. No, it's obviously we've had some painful fits and starts. Our primary aircraft, a lot of them were designed in the 70s and 80s. We got to get it right this time. We cannot do another false start. And the Army's not asking me for advice, but if they were, I would just say.
That's why you're here. Give it to them. It's a chance.
Yeah, we really have to go for what's the 80 to 90% solution we can go for today that we have a high certainty of getting done, and then ideally target technology insertions that aren't maxed out, that they have growth potential for the next few years. And as I said before, also if that technology is already available on commercial platforms, leverage what's there and their development cycle, and jump on. There's certainly an awful lot of opportunity that's being developed in the commercial aerospace industry that can hopefully make FVL a success on time and frankly on budget, because
Great points. Great points. We used to talk about finding the knee in the curve. You can go that 100% solution and cost so much. Where do you get the best bang for the buck and requirements, capability, and affordability? So.
And industry plays a part in that. We're part of the good idea ferry pipeline of good ideas, and I think we need to temper that with something it's really achievable in the time frame we set.
Right. Well, again, I just want to thank you all for taking that. Standing here, I get to look back at y'all. Really look good on that big screen. Just so you know that. But thank you so much for taking your time. I mean, you know the positions these folks are in, to take the time to be part of this, and is only to try and make our community and our partnership better. So on behalf of Army Aviation Association of America, bless you for what you do for us and for the Army every day, and thanks for taking the time to be part of this. Round of applause for these folks. Thank you.